This is homework 6.2. Question, we gotta go to question number 1 here. Okay. The weights of the chocolate in Hershey Kisses are normally distributed. So normally distributed means it is bell-shaped, symmetric bell-shaped. And the mean is 4.5338. And standard deviation is 0.1039. Is the distribution a standard normal? No, it's not a standard normal, because when mu and sigma standard normal, to be standard normal, mu has to be 0, sigma has to be 1. So this is not standard normal. So is that standard normal? No, because standard normal distribution has a mean is 0, standard deviation is 1. That should be the answer. The second question, let me make it a little bit bigger. Okay. I'm gonna go that far. Okay. So now find the area of shade. Okay, so here, this is question number 2. So when mean is 100, I think this is IQ score, then the deviation is 15. Now, the area of the shade this is 80. Now, from now on, so it goes all the way to the left. Now, think of all the way to the left is negative 9999999. All the way to the right, think of this one as 999999. Those are the two numbers I'm going to use. So to find this area under this condition, you go to calculator, and then now I'm going to clear everything. Go to second bars and go to normal CDF number 2, and then lower is negative 9999, and then upper is 80, as you can see in the picture. And then mu is 100, it's no longer standard normal. Sigma is 15. So when you shade, we click one more time, so this area is 0.0912. Okay, so now they want you to write 4 decimal, so that is 4 decimal. So 0.0912. Okay. Right now, next one. This is question number 3. They want you to find the area. Almost same question. And then this in the middle is actually mean, which is 100, because mean is given as 100. Now, they want you to go from 95, so a little bit left of the mean, all the way to the right. So like I said, if you go toward to the right, we assume this 999999. Actually, you can have more 9 if you want to. So this is normal CDF 95 999999 100, 15. If you use TI 83. So you go to same function, second bars, normal CDF, and then you put in that order 95, comma 999999, comma 100, comma 15. Then that will give you this area is 0.63055. Then we round to 4 decimal, so 0.6306. Okay, so 0.6306 the area. Okay. Now, next one is question number 4. When you find the area, okay, here. Now, always middle is the mean. This is 100. So they want you to find between 70 and 105. Okay, between 70 and 105, they want you to find this area. This one's easy because they give you normal CDF again, and then lower is 70, upper is 105, mean is 100, standard deviation 15. Or you can do this if you use TI-84. Second bars, normal CDF, and then lower is what? 70. Upper is 105. Mean is 100, standard deviation 15. So paste and then click one more time. Then this area is 0.6078. And they say 4 decimal. So this is 0.6078. Okay. Now we're kind of going backwards in question number 5. Now they gave you the area. They gave you the area. This area is 0.97. Then what is this score? What is this number? That is a question. This middle is 100. Okay, so it has to be more than 100. Now, so in this case, you use inverse norm in your calculator. Okay, that second bars, you see this inverse norm, okay? And you write the area 0.97 and then 115. So 0.97 and the mean 100, comma 15. Then you get then this number is 128 round to 1 decimal 0.2. Or you can say, if you use the other calculator, if you use TI-84, same thing, second bars, go to inverse norm, and in that order, area is 0.97, mu is 100, sigma is 15. You paste, hit one more time, you get same number, 128.2. Okay, so I'm going to put 128.2, check the answer. Okay. Now, same thing, question number 6. They want you to find x. This area is 0.2969. Now, in the middle is 100. So we like to find this x value. X has to be more than 100. But you always have to give the area to the left. So this area is 0.7031. Okay. So you have to enter this area. So in other words, you have to say inverse norm 0.7031 115. That will give you x value. So inverse norm, the second bars, you go to inverse norm, and then 0.7031, 0.7031, and then mu is 100 and sigma is the same. Paste, and one more time. So this number is 108. Okay, so that is, I just score is 108. Right? Okay, let's go to question number 7. This is almost same question. Everything's same, isn't it? Question number 7. Now, they want you to find the x values corresponding this x value. This is 0.97. Then this left value is 0.03. So you enter inverse norm 0.03, 100, 15. So if I use this TI-83, second bars, inverse norm 0.03, 100, 15. So it is actually, well, in the middle is 100, right? So it makes sense. This is 71.788. Okay, and then when you round to one decimal, so I'm going to say x equals 71.8. Okay, so I'm going to say 71.8. Okay, right, that was number 7. Let's get number 8. Now find the probability that randomness of IQ is less than 115. So over here, this is 100, 115. They want to find this area. Okay, so find the area. So use normal CDF. What did I say at the end? Negative 999,999. So negative 999,999. And then upper is 115. Mu is 100. Sigma is 15. Okay. So normal CDF. Okay. And second bars. Normal CDF, and then negative 999, 999. You can put more if you want, it's okay. Comma 115, comma 100, comma 15. Then you get area is this area 0.8413. Okay, 4 decimal. So 0.8413. So 0.8413. Okay. All right. Question number 9. Okay. Now this time they changed the mean. Mean is 96.6. And the standard deviation sigma is 17.4. Now they want us to find probability or area. So in the middle is 96.6. Greater than 124.4. This area. Again, I want to go 999,999. Okay, this mu is that. Sigma is changed to 17. Well, I wrote it there. Okay. All right, now, so that area is normal CDF (124.4), 999,999, comma 96.6, comma 17.4. So normal CDF Second bars, normal CDF, 124.4, comma, 999,999, comma, 96.6, comma, 17.4. So you get area is 0.05505. So they want to write 4 decimal again. So this is 0.0551. Okay, so 0.0551. Okay. Now question number 10. They want you to find P95. Okay. P95 is 95 percentile. So 95%, this is 0.95. So this point is P95. So this point must be 0.05. Okay. So they want you to find this one. But what is it? It is a engineer, and then it is mean. This is mean 14.1. Okay, and sigma is 0.9. But we know it is 0.95. So what we have to do? We have to do inverse norm 0.95, 14.1, 0.9. So go to calculator. I'm going to clear that. Second bars. Go to inverse norm. And then in that order, what is it? 0.95, comma, 14.1, comma, 0.9. Then you get this point is 15.58. Then you write 1 decimal, so 15.6. Okay. So it should be 15.6. Okay. Question number 11. Looking at the x normally distributed mean is 104.7, and then standard deviation is 22.9. They want you to find Q1. You know what is Q1? Q1 is same as 25th percentile, just like a quarter. So if this area is 0.25, then this point is called Q1, which is same as 25th percentile. Okay. And then this point is 104.7. Okay. So now you need to find Q1. What is Q1? Okay. So we go to inverse norm. 0.25, 104.7, 22.9. So go to inverse norm, clear. Second bars, inverse norm. Go to 0.25, 104.7, comma, 22.9. So you get 89.25. This point is 89.25. Then when you round the 1 decimal, so 89.3 when you round. So it is 89.3. Okay. Now number 12. Kind of long here. Suppose that a heartbeat per minute of adult male has no. So mu equal, this is question number what? 12. Mu is 69.8, and then standard deviation is 11.7. Instead of using 0.05 identifying significance value, we use a criteria that a value x is significantly high if a probability of x or greater is less than 0.01, and the value is significantly low if p x or less is less than 0.01. So what that means here is anything, okay, in the middle is the mean, 69.8. Anything here, below here is significantly low. Any birth rate below here is significantly high. Okay, this area is 0.01. This area, same thing, 0.01. So what is that? This number significantly low. This number significantly high. That's the question. Okay, so we know that significantly low, this area is 0.01. So we're going to do inverse norm 0.01, comma 69.8, comma 11.7. That will give you significant XL. Okay, so clear. Second bars, inverse norm 0.01, comma 69.8, comma 11.7. Okay, then we get 42 point, this is, let me use 42.58, 42.58. When they round to one decimal, I'm going to say 42.6. Okay, so this is, you get X low. Now, to the same thing, inverse norm, the other one is, because this is 0.01, the other side is 0.99. 69.8, 11.7. That will give you X high. So what is it? Go to inverse norm again, second bars, 0.99, comma 69.8, comma 11.7. You get 97.1. 97.0. So this is 97.0. Okay. So now, heart rate with a BPM of more than 42.6 and less than 97 are not significant. Okay, because those values are not significant. Okay. Heart rate of 90. So if you have heart rate of 90 belongs here. It's not significant. This is not significant. Okay. So heart rate of 90 is not significant because it is inside the range of values not significant. Okay. Now, next one is question 13. Question 13. Engineers want to design a seat commercial aircraft so that they are wide enough to fit 99% of adults. Assume that, so they want you to find 99 percentile basically. Okay, 90 percentile, so they cover just about everybody. Okay, so this 0.99. Okay, this is P99. So this area is simply 0.01. Okay, and then mu is 14.2, which is this point, this one. Sigma is 0.9. So to do that, well, we did that inverse norm 0.99, 14.2, 0.9. Okay, so maximum hip width is that. So go to inverse norm and then 0.99, comma 14.2, comma 0.9. Okay, so this point is 16.29. So 16.29. If you approximate 16.3. Okay, so round to one decimal. So 16.3. Okay. Now, question 14. Oh, sorry. What condition would produce negative z-score? Negative z-score here. Question 14. Any score left of the mean. This is the mean. Any score left of the mean is negative z. Any score to the right of the mean is positive z. So the answer is z-score corresponding to value located to the left of the mean. Okay. All right, now go to 15. If you're asked to find 85 percentile, what is 85 percentile? 85 percentile means 85% is below you. Basically, that's what it is. This is 0.85. So this is P85. And this area is 0.15. So data value, let's say with area 0.85 to the left. That's important, to the left. Okay. All right. I think that's the end of it.